Hi, welcome. This is a lesson on greatest common factor, finding greatest common factor, and prime factorization. First of all, a factor is an integer divisor of a number. That means it's a whole number that can divide evenly into another number without a remainder. So if you were to take, for example, 7 and divide it by, let's say, 3, and I hit enter, I get a decimal, which means there was a remainder, which means that 3 is not a divisor, not a factor of 7. In this first little exercise, we're going to try to find all of the factors of the following numbers. And so we want to do that by pairs. So we're going to say, you always start with 1 because 1 is always a factor. You can divide anything by 1. So 1 times 10 is one set of factors of 10, and then 2 will go into 10, and it goes in there 5 times. So 1 and 10 and 2 and 5 are all of the factors of 10. If we look at 50, we'd start with 1 times 50 is 50, and 2 times 25. 3 won't go into 50. 4 will not go into 50. 5 goes into 50 5 times. So one of the things I'd like you to notice is that these numbers increase, these numbers decrease, and you end up getting to a point where if I go up, I'm going to find none of the factors exist in this particular list until I get to 25, and then it'd be 25 and 2, which is just a repetition of 2 and 25. So I'm done at this point. These are all of the factor pairs of 50. Prime factorization. The prime numbers that multiply together to produce the original number. Recall that the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and the list continues. But all of those numbers have in common that they have exactly 2 factors, 1 and the number itself. So the only thing you can divide evenly into 2 is 1 and 2. The only thing you divide into 3 is 1 and 3. Notice 0 is not on the list, nor is 1 on the list. Those are unique numbers. The only factor that 1 has is 1, and 0 has infinitely many factors, 0 times any other number. So 0 and 1 are unique numbers, but the rest of these are prime numbers. Notice also that 2 is the only even prime number. All right, find the prime factorization of the following numbers. 25. So I like to do this a little bit differently than you might have seen. 25, I would say I'd start with 2. 2 will not go into 25, so I skip 2 and I go to 3, and 3 won't go into 25. So I'm just going through the prime numbers, 2 and then 3, and then I'll go to 5, and I say 5 goes into 25 5 times. And so the prime factorization of 25 is 5 times 5, which can be also written as 5 squared. 100, let's try 100 here. So 100, 2 goes into 100 50 times, and 2 goes into 50 25 times. We've already seen 25, so we know that it is 5 times 5. When you get to a prime number at the bottom, you know you're done. So I don't list it separately. The prime factorization of 100 is 2 times 2 times 5 times 5. All right. Common factor. A factor that 2 or more numbers have in common. You can find common factors by listing the factors for each number. You can also use the prime factorization. So find all the common factors of the following numbers, 25 and 100. So we have already found their prime factorization. And so I'm just going to make note that they both have a 5 and a 5. And so we can say that, and that's all they have in common. So we can say they have 5 in common. They also have 5 times 5, or 25, in common. And as always, every two numbers has 1 in common with any other number. That's always a factor. 24 and 36. So I'm going to go off to the side here and write 24 is 2 times 12, and 12 is 2 times 6. 6 is 2 times 3, and 3 is prime, so we're done with 24. 36 is 2 times 18, and 18 is 2 times 9, and 9 is 3 times 3. So the prime factors that they have in common, they have 2 2's, and 1 3 is what they have in common. So we can list that they have a 1, they have a 2, they have 3. We know they have 4 in common because 2 times 2 is 4. They don't have 5. The 5 isn't a factor of either of them. If you take 2 times 3, that's 6. And then you can take 2 times 2, which is 4, times 3, which is 12. So they have 12 in common. And I believe that's it. So those are the common factors they have. Now, the greatest common factor, the largest of the common factors. So what is the greatest common factor of the following numbers? If we go back to example 5, where we listed the common factors of 25 and 100, we found 1, 5, and 25. But the greatest of them is 25. And I'll just refer us back to the work we've already done. The greatest common factor, 25. 24 and 36. Once again, we go back to the work that we've already done. We can see that the list there is 12. And so that's the greatest common factor of 24 and 36. You can also find factors, common factors, in the greatest common factor of monomials. For monomials, factor, the product of a factor of the coefficient and the variable. Common factors, a factor that 2 or more monomials have in common. And the greatest common factor is a common factor that the product of the greatest common factor, or GCF, of the coefficients and the most common variables in the monomials. So find the greatest common factor of the following. All right. So we say 24 is 2 times 12, and 2 times 6, and 2 times 3. And 56 is 2 times 18. No, excuse me, 2 times 28. And 2 times 14. And 14 is 2 times 7. And 4 we know is 2 times 2. But we'll list it to be thorough. And then 12 is 2 times 6 and 2 times 3. So we look, and they all have at least 2 2's. And then if we look at 4, it doesn't have anything more than the 2's. So in terms of the coefficients, the greatest common factor is 4. But then I look at this one, 24x cubed, and it has x 3 times. And 56 has x 7 times, and 4x to the 8th has x 8 times, and 12x squared has x 2 times. And so you're limited by the smallest amount that each of them has in common. And so 12x squared only has 2 x's. So we put those 2 x's together, and that is the greatest common factor of those 4 terms. We look at number 10. Once again, we know 6 is 2 times 3, and 9 is 3 times 3, and 4 is 2 times 2, and 21 is 3 times 7. And I ask you, what do they have in common in terms of their prime factors? And we can say nothing. They don't share any prime factors, which means that their greatest common factor is 1. They always have that 1 in common. So, but do they all have x's? They do. And how many x's does the least amount have? 9x only has 1. And so their greatest common factor in this case is x. You could write 1x, but usually we don't write the 1, so we just write x. And x is their greatest common factor. All right, let's do some more practice examples here. Example 11. X squared, x to the 4th, x cubed, and x to the 8th. Some of your teachers might actually have you write this out as x squared is x times x, and x to the 4th is x times x times x times x, and x cubed is x times x times x, and x to the 8th is x times x times x times x, 4, 5, 6, 7, 8. And so how many do they have in common? 2. And so our greatest common factor is x squared. Just multiply them back together, and that's your greatest common factor. Number 12. See, I see 5 is prime, and so I know that its only factors are 1 and 5. 5 won't go into 8, nor will it go into 19, and so their greatest common factor for the coefficients, the number part, is 1. And then x, this one has an x, this one has a y, this one has a z, so they don't share anything there. So their GCF is 1. They don't share anything else in common. They always have 1 in common. All right, 13. 32 is 2 times 16, and 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So I see 1, 2, 3, 4, 5. 32x to the 4th is 2 times 2 times 2 times 2 times 2, and then x 4 times. And 48 is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So I have 4 2's. 1, 2, 3, 4 2's times x 1, 2, 3, 4, 5 times. And then I have 8x squared. 8 I've done before, so I'm just going to say it's 8. 2 times 2 times 2 is 8. And x squared is x times x. And then 12 we've done also a number of times, so that's 2 times 2 times 3 times x. So they have all at least 2 2's. So I'm going to circle those 2 2's. And then they all only have 1x in common because the least amount has just 1x. And so I multiply 2 times 2 is 4, and then they have x. So their greatest common factor there is 4x. And then for 14, I'm going to break down each of these. 125, 2 won't go into 125, 3 won't go into 125, 4 won't, at 5 will, and it goes in 25 times. And 25 is 5 times 5. 90, 5 goes into 90. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 18 times. Oh, I should have started with 2. That would have been easier. Let's go back. 2 goes into 90 45 times. And then 3 will go into 45 15 times. And 3 goes into 15 5 times. And that's it. We're done. And 250, let's see. 250 is even. So 2 goes into 250 125 times. And then we see from over here that 125 is 5 times 25 and 5 times 5. So, do they all have a 2? No. The first one does not have a 2. Do they all have a 5? Yes. They've got 1 5 here. And so they all have 1 5 in common. And that's it. And so I can say that the GCF for the coefficient part is 5. And then for the variables, they all have x's, but they're limited by the one who has the least amount, which is 13 x's. So it's x to the 13th power, and that's your greatest common factor. If you wanted to, you could list out 13 x's and 24 x's and 42 x's, but you're still only going to circle 13 of each of them. So that's kind of the process. So practice, practice, practice. You'll get better as you work hard. Have a good day.